Hey guys, so today we're going to move on in measurement. And so our previous lesson was a quick review of area and perimeter, what they are, their formulas. And so today we're actually going to focus on area and how we can find the area of combined rectangles. Okay, so here I have a figure, and you probably noticed, it's definitely not just a regular rectangle. This is what we would call combined rectangle. Because it does have more than one shape in it. And so how could we, figure out what the area of this is by decomposing it? Okay, and so remember we talked about, decompose in math before. This word, we actually see it in other domains like science. And so in science, when you talk about a decomposer or something decomposing, it means it's breaking down. And so in math, it actually has the same meaning. When we decompose a number, or when we decompose, in this case, this shape, we're breaking it up, or breaking it down into smaller pieces. So how can we, decompose this figure or break it down in order to help us find the area? So there's, always going to be multiple choices here. You could say, well, there's a rectangle here. Okay, so you see that rectangle here, and then let me switch out to another color. And then you could say there's a rectangle or a square here. Okay, or another way you could envision this is you could see a shape going this way, the bigger one going this way, and then the smaller one going this way. So there's always going to be more than one option as far as how we can decompose, these shapes. So let's go ahead and move on. So I've chosen to break it up, the first way that I showed you all. So where the longer part, coming down is going to be my big rectangle, and then the smaller part on the side is going to be my square. So this is the same shape, it's just been decomposed into smaller portions. And I have the grids here just to kind of help us see the areas. So remember, the formula for area is length times width. So I could say that this shape here, okay, has a length, or we'll say width. We have a length of 2 and a width of 4. Okay, so then this portion would be 4 times 2. And then this portion over here, it's a square, so length and width are the same. Okay, 2 and 2. I'm not so worried about units of measurement right now, inches and feet, centimeters, things like that, because I really just want us to focus on, how to actually solve this problem. So I have my two portions, okay? And then what I would do is I would just solve those equations of area of each individual shape. So the first figure here has an area, okay, of 8, and we'll just say whatever unit it is, unit squared. And then the shape here has an area of 4. Okay, units squared. And so separately, I know their areas, right? And now to find their combined area, I would just combine their areas, or add them, in other words. So area of 8 plus an area of 4 means altogether their area would be 12 square units. So the total area of this figure would be 12. And I'm actually going to click back real fast, and let's just double check and confirm. So the nice thing with the grids is that you can, fall back on, the counting of the boxes. And this is just to introduce the topic, to kind of get you comfortable with it. But really doing the equations is better. So I'm actually going to go back to what we actually solved. So the first thing we did. So we said that this here had an area of 8. And what I like to do when I do these problems is once I figure out the area, so remember we said it was 2 times 4. So the area was 8. And I actually like to write the area in that shape. Okay. And then we're going to switch this to green here. So we said that the area of this shape here, 2 times 2 was 4. Okay, so I'm going to put 4 in here. And you can actually quickly see, because I do have the grids here, that there are 4 squares here and there are 8 here. And if we do add the 8 plus 4, we do get 12. So that work was correct. All right, so let's try another one. And like I said before, you can always decompose many different ways. So you might see, oh, I can really easily just kind of cut off this little extra piece up here. Or you might say, I can break off this whole section here. As long as it's a rectangle or a square, then it's okay. What you can't do is say, or I shouldn't say you can't, but it kind of defeats the purpose of making this easier. Let's say you wanted to get a little fancy and say, oh, I'm going to find the area of this shape and add it to the area of this shape. Okay, this is not a rectangle, because remember, a rectangle has 4 sides. Also a square has 4 sides. This has 1, 2, 3, 4, 5, 6 sides, so it actually does not meet the criteria of being a rectangle. So whatever shapes you decompose it into, make sure they have 4 sides. So what would the decompose the figure and find the total area. So let's go ahead and do that. I'm going to, I think I'm going to go this way. All right. So once I have my pieces, then I find the area of the individual rectangle. So this one has a length of 2 and a width of 3. So my equation would be 2 times 3 for area. Okay, so 2 times 3 is 6. And like I said before, I like to just put the area inside that shape. Helps me out. And let me do blue. I'm going to find the area of this figure, okay, here. And so this one has a length of 1, 2, 3, of 4, and a width of 2. All right, so this one, 4 times 2 would be 8. And again, we don't have, we could say centimeters square or inches square. Right now we're really just focusing on the number part. So, but when we do have a unit given to us, remember it would be in square units. So that would be an 8. So I'm going to put a big 8 inside of here. All right, so now I can add my areas together. So 6 plus 8 is 14. So my combined area, or my total area of this figure here would be 14 square units. Square units, because we don't know exactly what unit it is. And then there was another question here. Let me go back to full screen. It said, what would the perimeter be? And so this is something that we really do focus on area, but it is good to touch base on perimeter as well. So remember, perimeter is the length of all the sides. And since we have combined rectangles, we have more than just the 4 sides. And so with the grid here, it's actually pretty easy to count the perimeter. But we're just going to kind of remember, formula for perimeter is the length of all the sides. So we can still find perimeter. So let's just go ahead and see each side here. And if it's not labeled, we'll add a label to it. So we have 2. We have 4. There's this little side here that didn't get labeled, so this is a 1. And we have 2 and 3. And then this long side here did not get a label. So let's figure this out. There's a couple ways. You could just count each of the units. Or another thing is, this length here is actually the same as this length and this length. So if I just add 4 and 2, okay, I would get this total length here, which would be 6. And you can always count just to double check. 1, 2, 3, 4, 5, 6. Yep. So this is quite a bit. This is 6 sides instead of just the 4. So let's go ahead and kind of condense these. So 2 plus 4 is 6. 6 plus 1 is 7. 7 plus 2 is 9. 9 plus 3 is 12, and 12 plus 6 is 18. So this shape here would have a perimeter of 18 units. So again, same thing, just adding up the length of all the sides. It's just more sides. So let's do one more. So you might not, so you know, for your activity today, I'm still going to give you the grids. However, that's not always going to be the case. A lot of times you'll be presented a combined rectangle in this format here, where you know it's just the outline of the shape, and then they will label, if not all, most of the sides, and then it's your job to figure out, you know, the area based off of that information given. So you can't just kind of sit there and count all the little grid squares. So, but it's okay, we can do that. We can figure this out using our formulas and using our knowledge of area. So first step is always to figure out how you want to break your rectangles apart, okay? So what I like to do usually is I like to look for rectangles that easily, like their sides are easily marked, okay? So I see that this side here is marked 1, okay? So they've already given me, you know, like a length. And then I see this side here is marked 5, so this rectangle here looks like it would be pretty good to use. Okay, so this is going to be my first rectangle, and let me go ahead and get to where I can change my colors pretty easily. And then this is going to have to be my second rectangle because I really don't want to split it up anymore, make my work harder. All right, so I have my two rectangles. Now I just have to figure out their areas separately and then combine them. So let's go back to the first one I did here in purple. I have a width of 1, set area. Okay, remember it's length times width. So 1 times my length here is 5. And you're probably thinking, but what about the 7 over here? Well, I would only use the 7 if I was using the entire length of this line here. But you can see this is actually getting split apart between the two rectangles. So this side here is measured 5. So I know that this little purple section over here is also going to be 5 centimeters. So I actually don't need this 7 for this. For the way I've split up my rectangles, I actually don't need that 7. So if you want to, you know, you can cross it out if it kind of, you know, distracts you. That's the thing, is you're not always going to need all of the numbers that are given to you. It really depends on how you break your rectangles up. So the area for this rectangle here, okay, it's going to be 5, and they actually have given us the units here. It's centimeters, so it would be square centimeters. But I'm just going to put a big 5 inside that rectangle there. So now let me switch to my blue. Let me find the area of this one here. So again, I have 2, I have 6, and I have 5. I have a different, you know, number up here because you notice this line. Let me erase what I drew so you can kind of see the original one. So see how this line here, you know, it stops. It doesn't go all the way across. So this section here is only 5 centimeters. But down here, I have the entire length of that side, which is 6. So I actually don't need this 5. I'm going to go ahead and cross that out, okay, because it's not going to help me figure out the area of this rectangle here. I'm going to use the 2 and the 6. Okay, so this length is 2 and the width is 6 on this rectangle. So 2 times 6. So that means, again, and we're using centimeters, so that means that the area of this rectangle here would be 12 centimeters square. So I'm going to put a big 12 inside this one. So now I know I have found the area of both of my rectangles, and so now I can, you know, just easily combine them. So 12 plus 5 equals 17. And like we said again, our units were given to us, so squared centimeters. So the area of this combined figure here would be 17 square centimeters. All right, that's it for today, guys. Your assignment is a couple of worksheets continuing to practice this, and I'll see you guys next time. Bye.